Welcome to another episode of C# tutorial for beginners. This is part 2 of C# tutorial. In this course, C#.NET programming basics are covered. The instructions are to the point and concise, which makes learning C# easy. This video is about delegates in C#. Delegates are used to implement some important concepts in C# programming, like callback methods, event handlers, anonymous methods, and lambda expressions. Therefore, it is very important to understand delegates. In some programming scenarios, we need the ability to pass methods as parameters to other methods, and the other methods execute them as and when needed. This point is very important to understand delegates. Different languages provide different ways to achieve this. Let's get started. In JavaScript, functions are actually objects. So a function name can be passed to another function as parameter, and other function can execute it. In C language, there are function pointers. A function pointer is a variable which holds address of a function. It is passed as parameter to another function where it can be executed or saved for later execution. But function pointers are not safe and secure. Manipulating the address in memory is just risky. C# has delegate objects. You can think of delegates as special objects which can hold references of one or more methods. Delegate objects can be passed as parameters to other functions where these can be executed. In a sense, C# delegates are similar to function pointers, but these are type safe and secure. Delegate is a type in C#. It is a reference type similar to classes. Let us see how to use a delegate. As a first step, a delegate type is declared. It is similar to creating your own custom type like a class or struct. Delegate declaration can be done inside the class or outside the class depending on the scope. The second step is declaration of variables from the custom delegate type. And third step is adding references of methods to variables. And fourth step is executing the variable. Here is a syntax of delegate type declaration. You write the access modifier, then delegate keyword, then return type, then delegate type name, and then list of parameters in parentheses. It pretty much looks like a method declaration, except there is no implementation block and delegate keyword is used after the access modifier. The return type and parameters specify the form of methods that the delegate will accept. Methods with incompatible parameters or return type will not be added to the delegate variable. So the whole purpose of delegate type declaration is to specify the signature of methods which can be added to the delegate type. After the delegate type is declared, you can declare delegate variables like other variables. You write the delegate type name and then variable name. Here in this example, a variable v1 of type printDelegate is declared. Object creation can be done by using the new keyword and passing the method name in parentheses to the delegate type. Please remember, you must pass the method name as parameter in parentheses after the delegate type name. You cannot create any empty delegate object. In other words, the delegate has no empty constructor. Alternatively, you can assign the method name directly to the variable without using the new keyword. This is short syntax. You can also declare variable and assign a method name in one statement. We can assign more than one method reference to a delegate object. In this case, these are called multicast delegates. So a multicast delegate is just a delegate object which holds more than one method references. Each delegate object maintains its internal list of references. This is known as invocation list. To add more than one method references, just use the plus sign to add the methods, and then assign these to the variable using assignment operator. Or you can use the plus equal to sign to add an additional reference to the variable. You can also add reference of a method more than once to a delegate object, so the duplication is allowed. If same method reference is added twice, it executes twice when the delegate is executed. Similarly, You can remove the reference using minus is equal to sign. In this case, the invocation list is searched from bottom to top and removes the first reference if it is found. Otherwise, nothing happens. You can also add two or more delegate objects. In this case, all the method references from the delegates being added are obtained and added to the resultant delegate object. Delegates are immutable. It means you cannot modify a delegate object once it is created. Adding or removing a method reference to a delegate object always creates a new delegate object. The old object is garbage collected. There are two ways a delegate can be executed. You can call the invoke method of the delegate object and pass parameters in parentheses. Alternatively, you can write the delegate variable name and then pass the parameters in parentheses. Please note, when a delegate is executed, it executes all the methods contained in the invocation list. It is always a good idea to check for null before executing a delegate. Otherwise, there will be null exception. You can use if statement or null conditional operator to check for null. When there are more than one method references in a delegate object, value is returned only from the last method in the invocation list. Return values from all other methods are ignored. Here is an example of delegate usage. The purpose of this example is to show callback implementation using delegates. There are two classes, program class and sales order class. At the first line, a delegate type is declared. Its name is print delegate. Its return type is void and it accepts a string parameter. In the main method, a variable del is created from print delegate. On the next line, an object of print delegate is created using new keyword. And name of notify method is passed as parameter. So reference of notify method is added to the object. And then process reports method of sales order class is called and del variable is passed as parameter to it. And then process reports accepts the delegate as parameter. And then the delegate object is executed using the invoke method. It calls the notify method in program class and prints the message on screen. So process reports method is calling the notify method in another class indirectly through the delegate object without knowing the name of notify method. The notify method in this example is callback method. Callback methods are used to plug in logic at runtime to other methods of other classes. This technique is used to plug in custom logic to other classes without inheriting them. When a reference parameter is passed to a delegate, value of the parameter is changed after each method in the delegate is executed. Here in this example, a delegate myDel is declared which accepts a reference as parameter. Then in my class, a method add1 is declared. It accepts the reference parameter and adds 1 to it. Similarly, method add2 is declared. It accepts the reference parameter and adds 2 to its value. In the main method of my class is instantiated. Then a delegate variable is declared and references of add1 and add2 methods are added to it. Then an integer variable x is declared and its value is set to 0. Then the x is passed to delegate object by ref and the delegate is executed. And then the variable x is printed on the screen. So what's printed on the screen? The answer is 3 because add1 method added 1 to the reference variable. Then add2 method added 2 to the variable. In this example, we have used instance methods, whereas in the previous example we used static methods. There is a third type of method which is specifically used with the delegates. It is known as anonymous method. Anonymous methods are unnamed inline methods and can only be invoked through delegates. An anonymous method is declared at the point of instantiating a delegate. With normal methods, we assign a method reference when instantiating a delegate. Anonymous methods are not members of a class and cannot be executed explicitly from other parts of the code like other methods. Here is an example of anonymous method. At the top, a delegate type myDel is declared. It returns an integer, and then a variable mdel is declared from mydel delegate type. Then an anonymous method is assigned to the mdel variable. Please note the delegate keyword is used to write the anonymous method, and there is no name, and return type is also not written. But in the method body, there is return statement. It knows the return type from the delegate type to which the method is getting assigned. If the delegate has a return type of void, then the anonymous method code cannot return a value. So it makes sure that the return type of the anonymous method and the delegate are same. Normally, number of parameters, types, positions, and modifiers of the anonymous method must match with the delegate type. But there are two exceptions. The first exception is the PARAMS keyword. If it is used in the delegate type declaration, it must be omitted in the anonymous method declaration. If you remember, params keyword is used to pass variable number of parameters. And the second exception is that you can leave the parameters empty if none of them is used in the method body and none of them is out parameter. If you remember, out parameters are used to return multiple values from a method. Here is an example where the delegate type accepts two parameters, but because those parameters are not used in the anonymous function body, so the parameters received are left empty and there are no parentheses. Let us understand the concept of captured variables. Variables declared in the block of code in which anonymous method is declared are also available in the body of the anonymous method. Anonymous method captures these variables and uses them when the delegate is invoked. These are available for delegate execution even if these variables go out of scope. Here in this example, variable x is declared and a value 2 is assigned to it, and the variable is used in the method body. So the reference of variable x is captured by the anonymous method. But outside the code block, the variable x goes out of scope. But when the delegate is invoked, variable x is accessible to it, and it prints 2 on console. So where can anonymous method be defined? We can write them as initializer expression of a delegate variable like we did in the previous example. We can add an anonymous method to another delegate and assign it to a delegate variable. We can also pass an anonymous method as parameter in place of a delegate object. We can also write an anonymous method to assign it to an event. Lambda expressions. We have just covered anonymous methods. You can think of lambda expressions as a replacement of anonymous methods. These are less verbose and more clear syntax-wise. Anonymous methods were introduced in C# version 2, whereas lambda expressions were introduced in version 3 of C#. You can easily transform any anonymous method into a lambda expression. Here in this example, an anonymous method is declared using delegate keyword. On the next line, its equivalent lambda expression is written. First thing to note is that there is no delegate keyword written. The second thing is the equal to greater than sign. It is written after the parenthesis. It is called lambda operator or goto operator. And then in curly braces, method body is written. So we have transformed an anonymous method to a lambda expression. On the next line, it is more simplified. The data type of the parameter is omitted. You can omit the data type of the parameter because it is already known through the delegate. But there is a condition. You can only omit the data type of the parameter if ref or out keyword is not used in the delegate parameters. So in this case, no ref or out keyword is used in the delegate type declaration. So we can omit it. And if there is only one parameter, we can omit the parenthesis also. But if there are no parameters, we must write the empty parenthesis. And in the final declaration, curly brackets and return keyword is also omitted. It is because there is only one statement and it returns a value. Such a statement is called an expression. A single statement which evaluates to a value is known as expression. If there are more than one statements in the method body, then it is called a code block. A code block must be enclosed in curly brackets, and return statement must be used to return a value from the code block. What is an event? An event is a message sent by an object to signal the occurrence of an action. The action can be caused by user interaction, such as a button click, or it can result from some other program logic, such as changing a property's value. Message sending is called raising the event. The object that raises the event is called the event sender or publisher. The event is typically a member of the event sender. For example, the click event is a member of the button class. The event sender does not know which object or method will receive or handle the events it raises. The objects that receive the events are called subscribers. In order to receive an event, a subscriber must register or subscribe to the event of publisher and provide an event handler method. So in short, a publisher declares the events and raises the events, whereas a subscriber subscribes to the events and handles the events. A publisher can send more than one events and a subscriber can handle more than one events. Let us try to understand events with an example. This is a sale order class. It is a publisher because it declares and raises events. In order to declare an event, you need to declare a delegate type. MyDelDelegate accepts a decimal parameter and returns a bool value. Next step is to declare an event from the delegate type. Event keyword is used to declare an event. The name of the delegate type is written. The name of the delegate variable is written. It is same as declaring a variable from delegate type, except the event keyword is used. In this case, name of the event is amount changing. You can think of an event as a wrapper on a delegate variable. Value of the event is set to null by default. Amount is declared as property. Before invoking the event, it is checked for null. Then event is raised. The syntax is same as invoking a delegate. The result obtained is stored in bool temp variable. And value of the property is only set when the value returned by the event is true. The whole idea is to validate the amount before it is set. But where is the validation logic? Validation logic will be written in some other class which will handle the event. So here is another class. It handles the event of sales order class. So this class is subscriber. And amount handler method is written for handling the event. In other words, this is event handler method or callback method. This method returns true if amount is greater than equal to 1000 and also prints whether the amount is valid. In the main method, an instance of sales order class is created and then event is subscribed. Event subscription is just adding the method name to the amount changing property of SO. It is same as adding a method reference to the delegate variable. Please note that plus equal sign is used to assign a method. You cannot use only equal to sign. Similarly, you can unsubscribe to the event using minus equal to sign. On the next line, so.amount is assigned a value of 500. This causes the event handler method to print invalid amount message on screen. But when an amount of 2000 is assigned, it is printed as valid and event handler method returns true and value is assigned successfully. In nutshell, an event holds a delegate variable in it. Subscribing to the event adds method reference to the delegate variable. Raising the event invokes the delegate. To declare an event, we need a delegate type. C# has provided a standard delegate type to declare events. Its name is event handler. It is declared in the system namespace. All GUI components use it to declare events. Return type of this delegate type is void. It means it cannot return a value. It has two parameters. The first parameter is object sender. It holds a reference to the object that raised the event. Its type is object and can therefore match any instance of any type. The second parameter is event args, E. It is used to pass additional information. If no information needs to be passed, just pass null. Otherwise, pass an object of a class derived from event args class. Let's start transforming previous example. The first thing, I have created event args valid class. It is extended from event args class. It has two properties. IsValid property will be used to return a value back to the publisher. AmountToSet property is used to send value to subscriber. In sales order class, event is declared using event handler delegate. Then event args valid class is instantiated. Then its properties are initialized before raising the event. Value is assigned to AmountToSet property. Then event is invoked and temp object is passed as second parameter. The amount handler method receives the parameters as event args and casts it to event args valid class. Then accesses its values, finally sets the value of isValid property. So there is no return statement, but this value is accessible in the sales order class. So it is another way to return value through a parameter. Okay, this topic ends here. Please ask questions in the comments section and let me know your feedback. Subscribe to my channel for upcoming videos on C#. And also like and share this video with your friends. Happy coding. Thanks.